Goedemiddag allemaal. Good afternoon. I think we should start off this round with a few introductions, because not all of you might know all of us. You know our names now, but I think it helps to give a little bit of background, because there's quite a diverse and interesting cast here. Unfortunately, Leo couldn't join us today, but there's still a lot of interesting speakers. I'll start off with a little bit about myself. So, like Rajiv said, I'm at Consensus Diligence. I mostly work on our product stack. So you might know Mythex, you might know Scribble as well. So this is what we've been working on more recently, together with our fuzzing platform. And this is all like to essentially build tooling for security analysis. And I know there's a few people on this panel that work on similar technologies, so we'll get into that a little bit more later on. And myself, I also like to spend my free time doing some bug bounties and fun stuff like that. Muli.
Hi, I'm Muli. I'm not very good at that. I am Muli Sagiv. I'm originally from Tel Aviv University. My research is formal verification and static analysis. I contributed major techniques to the area. One of them, probably the most famous, is the one integrated into the Microsoft device driver, basically device driver verification. I worked in other fields, basically theoretical problems, decidability in logic. But since 1998, Shelley Grossman, my PhD student, and myself, we founded Certora. The goal of Certora is to, it's complementary to auditing. I'll be able to talk later. It's a technology that integrates into your CI and checks your code. It integrated static analysis and formal verification. And this is my field. I've also worked in sort of verifying some practical experience, especially avionics software.
Yeah, I'm Martin. My background is in mathematics, or at least that's what I was studying. And then I started working in the ETH space, did some projects, a little bit at Consensus, and then Maker, writing a little bit writing the contracts that were involved in multi-collateral DAI, but more analyzing them for safety. And using the tools that were available at that time, and then progressing to the Ethereum Foundation, sort of developing our own set of tools that we could use that sort of addressed some of the shortcomings that we found in using the state-of-the-art technology at the time. And then in parallel to that, I've also been doing some audits, so putting these tools to the test. Yeah, that's me.
Hello, I'm Adrian. So I also have a background in academics in computer science, but now I'm mostly a Solidity developer. I'm solely a Solidity developer at OpenZeppelin, working on the smart contract library. OpenZeppelin is dedicated to helping secure the open economy. We do that in a number of ways, including audits, but also development of tooling like Defender and Contract, which are hopefully the building blocks of a more secure Web3.
Hello, I'm Everett Hildenbrandt. I'm at Runtime Verification. We do audits and security, but we also do a lot of research into formal verification. In particular, we're interested in developing sound tools for all programming languages. So not just blockchain-specific languages, but also C and Java and Python and these other languages. But recently, we've been focusing a lot on blockchain languages because, good revenue. So.
Awesome. Thanks. Okay, I'll start off on the left with the first question. Muli, like he said, has an extensive background in formal verification, and one thing I think is interesting is like your experience in verification of non-Web3 systems and kind of how that experience reflects on verification of smart contracts. And I think there's two sides to this story, and you can reflect on both because you guys at Certora both build verification tools and use them. So yeah, I was wondering what's your take on that?
Yeah, so first of all, I want to acknowledge the fact that in my field, there are a lot of people who know much more than me on practical things. I'm academic, and mostly I work on basically algorithms. Even the work that I say about Microsoft, I wrote the algorithms, but the people who implemented it spent about 6-7 years. I wrote the algorithm, it took me a year, and then they spent 6. And so basically, I'm not the guy who tried to get something into practice. But I can tell you that I did try in the context of Airbus. So you all know Airbus, which is basically developing avionics software. And they tried to get basically their code to be right. And I was one of the guys who were helping them. And we were actually trying to get this thing to work. And it fails in so many ways. And in fact, it's very, very hard it was very hard to us to get things to work, because this is a very, very different domain. These are C programs, or actually they're C programs which are generated from state machine. It doesn't matter. The story is long, but it failed in many, many ways. And one of the problems that happened for us is that we found so many errors in the plane, but none of them were real. So this was actually very, very, and it was actually, we as human, it was so hard for us, because people say if somebody knows what you are doing, nobody will fly anymore. So basically, the experience was very, very different. I think the issue of Ethereum is very, very interesting, because we have a small code which carries a lot of value. So that changed the story completely. In fact, we are finding out that many researchers in our field, if you look, they're actually looking into this field because you guys have found something which is very interesting for us. And I've worked in many times trying to apply software. And for example, we have verified consensus protocol together with Microsoft. That's interesting, but the consensus protocol doesn't change. You verify it once. And the ideas with smart contract is more interesting. So I think this domain is actually, it's almost like the killer app of our field. If crypto dies, I have nothing to do.
Awesome. So, is there anybody that would like to expand on that? I know Everett also works a lot in verification of non-smart contracts.
Yeah, well, I think I was thinking more interesting things about the Web3 movement and how it's enabled like formal verification. But I think two things are interesting. One is formal verification in other fields usually comes from a desire to be, like regulatory compliance or safety compliance or something like that. And from crypto, it just comes from the desire of like, I don't want to lose my money, right? Like so it's kind of like somehow it's like almost more a grassroots desire or something like that. And then,
or it's a marketing desire.
Or marketing.
People want to say there was an artist.
But it's less regulatory compliance, right? It's more just like people want it, and so the market kind of arose, as opposed to like, the FAA demanding like every plane has to have these checks done on their wing structure or something like that, right? So it's a little bit different of a market in that regards. And then I think it's also just like somehow, the small code size, and it's more organic and tractable, and I don't know, people are trying things. I think it's exciting. So
I think also, we have to say people are willing to pay more. Okay.
Yeah, that's true.
And is the threat model different because bytecode on the blockchain is open to everybody, whereas the firmware in an Airbus is not visible to attackers, hopefully. So does that really change your scenario for verifying that?
Yeah, it changes completely. It changes things completely in this. Also, the type of errors that we are finding in this smart contract, they are so much more interesting. We are finding solvency issues. Solvency issues means that you deposit money and you cannot withdraw it. In the Airbus, we found very simple cases that says that they are actually significant. For example, we found a case that if the plane is flying more than 7 hours, then in fact the navigation system breaks. It actually is important, although it was for a short flying flight. But it's a very, very different kind of errors that are found.
Cool. So a quick question then. You guys at Runtime Verification, we mostly build tooling, my company or Consensus builds tooling for Ethereum. Satora also is focused on smart contracts, but Runtime Verification has multiple languages. So in terms of demand, do you also see a much higher demand in the Web3 space than other industries?
Yeah, there's a lot more demand right now in the Web3 space, but really it comes down to how many dollars are at stake divided by how many lines of code there are. That determines how extensive your software quality assurance pipeline can be. So for our C languages, we are mostly shipping like testing and monitoring tools, not as much formal verification tools, because the code bases there are on the orders of millions of lines instead of thousands of lines. So there it's, okay, you could use CBMC to do some formal verification, but it's less tractable to get that kind of same high degree of confidence. So it's more like testing and analysis and monitoring tools that we're shipping for the C side of things, and less of the verification.
Cool. Sticking with the topic of formal verification for a bit, I mean, this panel is kind of a bunch of formal verification people, so I kind of have to. One of the things or issues that at least I've experienced with formal verification tooling is the user experience, let's say. It's not always super easy to use. Some people even say you need to have a PhD at least to be able to use some of these tools. And Everett, I was wondering, like, what kind of things can we do in general, and what kind of things does runtime verification do to, I don't know, make it so, make this technology that can be so valuable, more accessible to developers?
I don't know the answer to that question. I think the best idea I have right now is pushing on property testing, because it seems that there's evidence that developers are willing to learn how to do property testing, basically. And that's like
Can you elaborate a little bit on what property testing is?
Yeah, property testing is where you take your unit test and give it kind of symbolic inputs instead. And then what that enables is fuzzing or random testing, where you can now run that same test on a bunch of different inputs, and now that one property test becomes like 1,000, unit tests or something like that. But you can also, for a property test, do symbolic execution and prove that the property test holds in all cases. So somehow, like, developers are here where they're able to write unit tests, and we're all up here where we're able to do formal verification, but that's, requiring quite a bit of training and expertise. And property tests are like right here, right above unit tests. It takes a little more training of the developers, but suddenly unlocks, like, we can come down here and say, like, oh, we can take advantage of these property tests and do something with them from the verification side.
Yeah, I think this is the goal of the testing format that we introduced with DS Test and DAppTools, later adopted by Foundry as well, which is that you basically pull a bait and switch on developers, where you encourage them to write tests, like concrete unit tests or integration tests ideally, and then you just nudge them into thinking which variables can be abstracted, and so generalize the test. And then finally, you have cajoled them into formally verifying their smart contracts, and they think that they're still writing tests.
Yeah, so actually, it's interesting. I want to actually contradict the two gentlemen here. So one of the things that was very surprising so far, so formal verification, you need to solve only two problems. One is to write the specification, and the other one is to get the verification to work. Whether you're using runtime verification, Sartori, it doesn't matter. And both problems are hard. And one of the things that I noticed when I was working as an academic, that it's very hard for people to write formal specification. And if you go back, the place that people really succeed with formal verification is formal verification of hardware. So basically, there were some companies trying to do formal verification of hardware because verifying hardware is useful. But writing formal specification turns out to be very, very hard for engineers. This was, in this case, electrical engineers. What we are finding, which is very surprising, that in this community, people are willing to write formal specification, and in fact, some of the team write interesting formal specification. So, for example, the compound team, this is one of the teams in this space, they actually wrote a fairly interesting specification for money market. And it was very interesting for us to see that. We are actually working with some customers that tell us, look, we want you to write specification, but in fact, after the project, they can continue on themselves. And actually, I want to point out the Maker team. Maker team actually came to us after they understood things from working with K, and now they are writing their own spec. And it's amazing, actually. They are coming, and you look at their spec for layer 2, they are actually fairly complex even for us to understand. So I think in this domain, it's true. tools like Foundry are very useful, and we have now. We are building a plugin to Foundry. We have a plugin to VS Code. We are connecting to unit tests because we want people to start low. But there are actually people who are willing to write real specification, and they are writing things like even properties like solvency. They are specifying interesting properties of money market liquidation. So in fact, in this domain, people are willing to write specification, and the advantage of that is that they get some kind of assurance on the code, and they get their bug early, especially when they change the code. So I think in this domain, people are willing. We need to give them the languages, but they will eventually, maybe not everybody, but some of them will write the formal specification, and we need to give them powerful mechanism for doing that.
I think also if the development and the design process is mature enough for the protocol, they will be writing the specs in conjunction with the implementation, and they will sort of, I mean, not do a complete like correct by construction thing, but they will at least, have a white paper that actually explains in rigorous enough terms that it can be translated to a formal spec and at least be tested for some properties. And this is a super nice way to write smart contracts, to think of this like dialectic between your specifications and your implementation. So I recommend people do it.
Cool. So I want to give Adrian a chance to comment on this, because he is really the authority here on the panel, because he's an actual user. Like, what's your take on this? What do you think about property-based testing in the format that comes with Foundry or DevTools or like Brownie uses Hypothesis versus like stronger verification like Certora or K?
Well, I've got some pretty bad experiences in the past with formal verification because the tools were just not mature enough. And from a developer's point of view, I was like pushed to write invariants, like properties on my code, which I did, and then put them in what from a developer's point of view is just a black box, and you don't understand what's happening. And you either get a green light or a red light. And if it's a red light, sometimes you also get a counterexample, which is always super useful. But back in the days, the tooling was just not powerful enough, and basically it assumed that my code would never be able to run. It would always revert because it was unable to infer a set of input that matches some hashing and stuff like that. And so basically the code was running on empty set, and every property was good for the empty set, and my code was all green. And we proved that properties that don't exist were here. That's how we detected that. So from
which tool?
I'm not going to name anything. No, I mean it was a few years ago. I was not even working from OpenZeppelin back in the days. But the thing is, from a user point of view, it's really interesting because it opens a lot of properties. But it's quite a jungle, like all these tools that are difficult to understand, and you don't always know what they are doing. So, like really, from my point of view as a user for adopting these tools, first making them easy, like to use, like it's really improving. That's a very good point. Like something that was just discussed, maybe at some point we will have like the specification embedded directly into the Solidity code, for example, to NatSpec. Maybe that's something that could really improve the experience as a user, and then really have good feedback on what the property, how the property will run, and not just having a good or wrong result, but really have good insight on how the branches were run. And we are starting to use formal verification tools in our code, but that's just an addition on top of what we already have, which is human written unit tests with coverage reports, that kind of thing. And yeah, personally, I'm kind of old school. I like having people read the code and understand it, but hopefully, like, I mean, and again, like, I think the Swiss cheese slices model really applies to this space in the sense that no single solution is perfect, and we really need to add those. So it starts by reusing code that is provided by trusted and quality sources like OpenZeppelin, having good coding practices, having good testing practices, and to me, for verification is just one extra slice, or maybe multiple slices, depending on how many tools you're running, that are going to improve your security by a lot, but it's not the place where I would start.
Cool. So one of the things like I'm in the formal verification or fuzzing space, and one of the things I hadn't thought about too much is what kind of security can be provided by libraries. Like, how can you design a library, or what part of library design can help people build more secure smart contracts? And so, well, you work on the Open Zeppelin libraries, and well, I'm pretty sure everyone here has either used them or seen them, or worked with people that use them. So what are the kind of things you think about to help, or do to help people build secure smart contracts?
So I think it's a very different point of view of building libraries and building formal verification tools. Because the formal verification tools, they work on code that is finished, possibly even already compiled directly at the EVM level, which is even better because you would catch compiler bugs. And that's amazing. But we are on the other spectrum. We are trying to write security before user even start writing code. We are basically trying to provide them with fundamental blocks that sometimes they will reuse, but most of the time they will modify. So we need to imagine how the potential stuff, and it's always limited, but we try to imagine whatever users are going to do, what functions they will try to override, and try to make sure that the rest of the contract will hopefully remains valid, even if some function is edited. So we really think, and we don't have really tools for that, unfortunately, but we really try to think as humans about invariants in our code, like what are the strong invariants we can have, that if one function is modified, we are trying to keep it as much as possible in the rest of the code. And one of the consequences is also that we are not just thinking about like external interfaces that users will be able to call and that you can apply fuzzing on. We are also thinking about designing internal interfaces, which are absolutely not standard in this space, about how can we divide internal code in a way that we are really separating concerns.
Yeah, I think that's a really good point of trying to formulate invariants or somehow create a useful abstraction for these libraries that you're using, what they actually do. Because if you don't have that, then the library, you're not getting anything out of the library. It's just going to be some piece of code that you're using. And since it's not abstracting anything, the only way that you can learn what it actually does is to read the entire thing, and you have no guarantees whatsoever. But if you have, sensible tokens that don't do crazy stuff, then you can know that certain invariants about the balances are maintained and stuff like this. And I think it's a good direction to go.
So I think actually, if you look into our website, we have actually templates for ERC20, and we are finding them useful. You can have template for invariant, and in fact, it's exactly like your template for SafeMath. So we have template for invariant, and people instantiate them in the way they want. It's not we want to improve, but we want to make specification easier. Things like no double spending, we want to formulate it, and that's what we want to do, because we want to make, at the end, we want to make the specification easier, and specification is repetitive. You have a lot of cases that people are building similar things, so it can change. The specification is like you are saying, that library is a piece of Solidity, specification is a piece of our own language, but you can reuse it in the same way, actually.
And I think it would be interesting to compare the two, because one of the way we achieve this kind of separation of concern is all our storage is private. We don't want anybody to touch the storage directly, and the storage is touched by using functions like the underscore transfer that are external, that you can reuse, but that bundle things like, I'm not going to change a balance unless I'm also verifying that the total supply remains valid and that I'm meeting an event. And it's possible that maybe these blocks that we have internally as function that we expose, basically they would translate almost one-to-one to invariants that would be like your formal formalization of what the ERC20 standard is.
Yeah, maybe it would be nice to at some point actually write an ERC20 spec and not just an ERC20 interface, because I think like everybody here has at least written one of these specs, and if we just put it in the EIP repository, then maybe we can talk about the actual spec of tokens.
A lot of
I don't
things.
think any of the existing ERC20s would be like. I think they're all so
That's fine.
different,
Yeah.
right? Like
That's
there's
fine.
return true
Well,
or don't
no,
return
but-
log events
but-
or don't log events.
There are a lot of undefined behaviors.
Include all these things, but
But that's actually I don't agree here, because the idea is you don't have to think about it in a holistic way. You look at it as properties, and some properties. And if you look in our
this
spec,
is ERC20 2.A.3, which means it has the
No. So the idea is this is an ERC that you can mint. This is an ERC that may preserve your balance. You're looking into properties, and people from outside. There is, I don't know if you know this guy calling Boring Crypto. He's actually the originator of Sushi, and he actually built a tool on top of our thing that checks ERC20. It's actually public, and you can see that on the ERC, for example, it checks if you own the token, if you don't own the token. So basically, it gives you. It's kind of a dashboard. And it gives you the properties that hold and doesn't hold.
Yeah, at least it would be good for if you have a protocol that you say, okay, I can't have fee-taking ERC20s, then you just check that box. I don't want fee-taking ERC20s, and it removes that from the spec or something like that. But actually, I have some questions for you, Hadrian. How much are you using verification tools and stuff for the existing OpenZeppelin library? You mentioned that you're using some tools and stuff. And then also, what do you think about this discussion we had about property testing versus some other spec language? Or you said you had some bad experiences with formal verification in the past. I'm wondering if you've used the more modern tools like HEVM or some of the more modern fuzzers as well for developing these libraries, and have any opinion on them?
So right now we are working with Certora on having the OR code. I mean, our design process for code is very long, and we try to do the things the best way, and it goes through like good code practice with PRs on GitHub and continuous integration. And the idea is that we just want to expand the set of tests we have. We have like tests that are very, very classic, like just like coverage. We have tests that are, as far as I know, unique to us. Like we are checking that it's possible to do C3 linearization of all our contracts. Because we could design them in a way where they all work independently, but when you try to merge them, you get linearization issues. And that's the stuff we start adding into our continuous integration. And we are working with Certora on getting specifications for version 4.0 or for contracts. The objective is to get that into our continuous integration workflow. Hopefully in the future, integrate that also that we want to expand this set of invariants that are and properties that are being designed, so that future contract will be covered as well. We've had it. I mean, it's not really the same thing, but we've had it Slither checks pretty recently. It's also something that we need to first completely understand the tool and make sure code is really clean, because sometimes there are also false positives that we want to really understand before we make that part of like the restrictions on merging code. But it's coming.
So actually, just follow on. I don't know if you probably do know, but once we work with you, we wrote a specification for you. You put them in the GitHub, but then people are using them automatically.
Yeah.
Cool. So, perfect. Like more verification, more better. So we've talked a lot about verification, but really, like the staple of smart contract security is auditing. And Martin, you mentioned you've done some audits yourself, and I mean, one thing that happens every once in a while is someone suggests that auditors should be held responsible or be liable for like hacks that happen. Well, I have my own thoughts about this, but I was wondering whether like you had an opinion about this.
Yeah, I have several. And the first one being that the person that will always have the most liability is the party that is launching the protocol and encouraging people to use it and is profiting from it. Like, these are obviously the people who are taking in other people's money and profiting off of it. So I think the greatest liability should always lie there. I mean, when we speak of liability, like it's maybe for better or for worse, like it's an ambiguous term, whether we're talking about like financial liability or just whether you're getting flamed on Twitter, which I think is actually a pretty appropriate remedy for a lot of auditing that happens that is very low standard. because it is a lot about reputation. I mean, that's what an auditor is. If they wouldn't have a reputation, there would just be some person doing code review, which is nice as well. So what is my opinion, really? The discussion is starting in the wrong place, because it's sort of seeing an auditor as somebody that like comes in for 2 weeks and magically purges all of your code from the problems that have been rotting in there for years. And this is completely unrealistic. And the auditor has no stake in the thing. Like if you asked any auditor about something that they audited, whether they would recommend you to put money in it, everybody would say no. Like, I looked at it for 2 weeks and I would never do it. So you shouldn't either, unless that's your kink.
I only put money in things that Martin has audited, actually.
I only do whatever.
I think in ancient Greece, people were paying their doctors while they were healthy. And if at some point you got sick, you would blame it on the doctor and it has to cure you for free. So I don't know if that would apply to our space, but maybe there is something we can do in that regard.
Yeah.
I don't think it's practical, though, I don't think it's practical just because all the auditors are backlogged so much, right? So it just won't work mechanically, I think.
So, from my point of view, I think there's an incredible limitation on what you can do as an auditor in 2 weeks. There's going to be teams with not great code, and they're going to come to an auditor and say, well, I am only going to pay for 2 weeks, please do what you can. And then they're going to sell that audit as like, it's nice now, which isn't always the case. So I think there's only so much people can do. I'm not sure you guys probably agree. But are there ways that we can maybe increase like this factor of skin in the game, such that like you improve incentives if they aren't like all right already? Like that might also be a real situation.
Yeah, I mean, I as I said again, I think the people that are taking other people's money should take it seriously. Like you shouldn't be pretending that you're testing in prod and whatever, and then oops, all of these people actually lost their money and the test, turned out in a certain way. Even if you're pretending that nobody's supposed to use your contract, like in practice, it's not a very believable strategy. And I think the serious teams also in the space are taking it seriously. I mean, maybe they're doing it for just their personal work ethic, or they're doing it for regulatory reasons. But I think that's where the initial discussion should be. What responsibility do you have as a person who is launching a protocol that may end up costing somebody's their savings?
Yeah, so maybe I can say our experience, because we are not exactly an auditor, although what we are doing has some similarity to auditing. We have cases that people found bugs after us, and the problem most of the time were that we didn't write the right specification. So what happened is that it wasn't actually a tooling issue. It was the case that we didn't write enough sufficient specification. And what we are thinking is actually create a mechanism where the community contributes specification, and then they will get reward basically every time from us when we use the tool, because we are building a tool into CI. So we want to create incentive for people to write specification, and if they write specification and they are not, if the protocol itself in writing specification, that's great. But if somebody outside is writing a specification, then they can get a reward. And we understand that it's not a full bulletproof, but you can improve the specification every time you find something. So we are at the end, it's the issue of how to increase security. And the auditor do. I mean, we are working sometimes with auditors, and we see that they are finding fantastic things. So you want to create some kind of alignment that everybody would like to improve security. That's my take on it.
So essentially you're saying, well, there's one part, the responsibility we've been talking about, but we can do more, and this is kind of the crowdsourcing that you also do with a bug bounty, but in this case a specification bounty, I guess, yeah. that adds another layer of security, helping teams even more to create secure code.
Yeah, that's actually something that I think is very important, because I love auditors. I mean, I've got a lot in my company, but I also think that, again, we need additional layers, and community review is really valuable. You need to have strong incentives to have the community try to look for bugs in a positive way, because they might just write specification, but they might also exploit the bugs. So you want them to do that in the nice way. At OpenZeppelin, with our smart contract, we partner with Immunify to also have reviews by the community, and also, I mean, first because it's a different mindset and it had something different than an audit and formal verification, but also because, like, auditors, as we discussed, are fully booked for months ahead. So you need to do whatever is good for your security as a protocol or as a project, and don't underestimate the community.
Yeah, I think also there's an education component where people need to understand what it is that auditors are doing. If you have an airplane or something, you have the aluminum on the airplane in the wing, you're not trying to show that aluminum will never ever fail. You're trying to show that the failure rate is low enough that the plane will be able to run for 40 years, carrying people, across the Atlantic twice a day without any failures, right? So it's the same thing with auditing. You're not trying to show that the code will never fail. Ideally, you could show this, but maybe you miss a specification. Maybe you don't check this part of the code because the client said don't check this part of the code. You only check this part. Something goes wrong where you're not checking something, but the goal is to push back the failure time, right? There's every contract is probably going to have some failure time. Maybe it's 2 months, maybe it's 2 years, maybe it's 10 years, something like that. But the people who are looking for these failures are highly motivated. They can sit there all year and find one failure a year, and that's enough to fund their entire efforts of finding these failures. So they can spend a lot of time with the code. So the goal of the audit is just to make sure that you can't find one of these failures within the reasonable lifetime of the contract, which might be 2 years till V2 is deployed. Okay, if a hacker was sitting down for 2 years, they wouldn't be able to find that bug that would take them 5 years to find, right?
Yeah. So I've had the privilege to ask these amazing people all my questions, but I'd like to invite some of you guys to maybe ask your questions as well, if you have any, with the time that we have left. And I think there's a microphone somewhere. There should be. Otherwise, you can come up here and borrow one.
Thank you very much, guys. Really interesting. So I was wondering about the formal specification and formal verification. Would it make sense for a library like OpenZeppelin to ship a formal specification of the library, or do you have to take the software as a whole?
Maybe Adrian first, and then one of the formal methods versions.
So, it would definitely be interesting to ship formal verification, like properties that can then be applied to a set of tools and that people could reuse to verify that the way they modify the code is not breaking anything, which could happen. It's a different product. It's different from the contract. In OpenZeppelin, we have quite a few products. In the contract team, we have the contract for Solidity, the contract for Cairo. We have the upgrades plugin that is here to help you do upgrades. We've got all these things that are targeted at the end user, and we've also have internal tooling that is not aimed at the end user. Our tests, for example, are not designed to be reused. People do reuse them, but they have not been designed in this way. If we wanted to make them if we wanted to ship them, and basically we're also taking some form of responsibility that whatever we're providing in terms of tests or properties is good enough that you could use it in a context that we don't control. That's something we don't advertise, we don't do. Maybe it would be an interesting product that OpenZeppelin could build. Maybe it's an interesting product that someone else could build as well.
Yeah, so I think before we mentioned like this template for ERC20s, like we've built some in Scribble. You mentioned there being Certora templates. That will be one thing that it exists already. But I believe, well, with Scribble, but also with Certora tooling, that you could do the very same and create a spec to go with it so that you as a user can use it as verification. Though I think, like we talked privately before, there's you don't necessarily want to share your test suite, your full test suite, or like the Open Zeppelin test suite, because it might give a sense of false confidence, maybe. But maybe other people.
Yeah. So for most customers that we work, including, for example, if you look Aave V3, which is the most recent, and Benki, and the spec is there actually. As part of the Git, there is a directory called Satora, and you can see the spec, and you can see exactly what we verified. And even if there are failures of the tool, we document them completely.
Thanks.
It almost seems like you're asking a question about compositionality of specs, because you were asking whether if you have a code base like Open Zeppelin, whether you want to have a spec for the whole or like for the parts.
Yeah, I was wondering if it's possible to do for the parts, or like an audit usually happens in the whole code base because they need to have all the context.
Yeah.
We didn't know about formal specification.
Right. I think because if you have a scalable, which in this context means compositional proving engine, then of course this is exactly what you want to do. You want to be able to plug in the various components, and you want to reuse the smaller components in your building up your larger proof. And this is definitely a way to make libraries go from just extra proof obligations to actually being assumptions that you can rely upon in your code base. So.
Yeah, and this is actually a fantastic topic. It's still a research topic. So, for example, when we verify one protocol, say Compound, and Compound is calling Uniswap, do we need to verify Uniswap? So our idea is we don't want to verify Uniswap. We end up writing a spec for Uniswap. This is called Relay Guarantee. So it's a beautiful idea because verification is not a scalable technique. So if you reduce the size of the code, you make the code more secure and easier to verify. So we are going there. It's not easy for us, but we have in our spec language, we have summaries, we have mechanism to allow compositionality.
Thank you very much, guys.
Awesome, that was a super extensive answer. I'm really sorry, we don't have much time anymore for questions, but I'm sure the speakers will stick around. I wanted to ask, do you guys have a takeaway from this panel, or a final statement you'd like to make? And let's start with Everett.
Now I have no time to think. Yeah, I mean, I just think people need a clearer idea of what they're getting out of an audit and what they're getting out of formal verification. I think that's key. All the different firms are offering things that are slightly different, and they're all attacking security from different principles. And so people should, just talk to lots of firms and see what they're doing. And it might be that you find, okay, in my team, we're already doing X, Y, and Z, so we don't really need another firm to take care of that. So, we'll talk to this other firm that will take care of A, B, and C or something, right? So there's a whole different bunch of approaches to security. None of them are bulletproof, right? All of them have flaws. You have to really do your own due diligence to figure out where you need more security in your process. And just that thinking about security from the start will improve your code.
Maybe one thing is that at some point when you're building a project, you almost always want to go through an audit. You should want to go through an audit. And auditing time is difficult to find and super expensive, and you want to help the life of the auditors by doing as much stuff as you can beforehand. That includes using trusted contract, possibly like Open Zeppelin, but also trying out tools that are available and properties that are publicly available, and try to run that on your own while cleaning the code before the audit starts. That's how you're going to get the most money out of your audit.
Yeah, I think I'm going to go with the take that, as we spoke about before, sometimes I get kind of frustrated with this complaint that there's too little auditor time and everybody needs an audit before they launch their product, when it's really indicative of people just writing bad code to begin with and sort of outsourcing everything that has to do with security, hoping that a 2-week audit is going to magically solve all of their problems. I think if you're writing smart contracts, you need to learn what the fuck an auditor is doing and apply that when you're writing your code, so that you don't. I'm not saying that you should be arrogant. Of course, you shouldn't think that if you study the tools that we're using for a couple of weeks, you can do your audit yourself. But I'm saying that should be your goal. This should be the goal of any protocol that is, consistently putting out Solidity code that they know, that they have at least an idea of how secure their code is. even before they go to an audit. Yeah, that's my take.
I agree with all of you. I want to say there are two things that are important in addition. There's no such thing. Writing good code is a very, very important thing beyond everything. And for us, start formal verification early. Most customers that come to us, they come too late. The beauty of our technology, and that's actually, they come also to audit or too late. When you're thinking of specification, it sounds like you want to write the specification last. I want you to start specification early. Often we come to our customer and we say, what is the specification? They say, forget about it, the code is wrong. We come later. Start writing specification early. When you think of your code, write this invariant. Whether you use our language or K or others, it's fine.
Or English.
Write specification early.
Yeah, shift left. Well, I'd like to thank all of these awesome speakers for joining the panel, and also for the amazing amount of work that all of you have contributed to this space. Like the amount of things like research and tooling these people have built, it's insane. So yeah, big applause.
Thank you, Julian.